components you need. In the industrial control world, you'd find several different cards available for pressure monitoring, temperature monitoring, things like that. We have 3 cards in our configuration that we receive in these cardboard boxes. We have 2 analog input cards, which allow you to read analog voltages from your computer or from your robot. You may want to connect one of those to a potentiometer, and that potentiometer may be connected to an arm on your robot that's moved up and down with a motor. By reading the voltage across that potentiometer, you can determine where that arm is positioned, so that you can use a joystick to move the arm up and down and know exactly where that arm is. An analog signal is a voltage from 0 to 5 volts or 0 to 12 volts. It's a continually varying voltage. So this is used to read different voltages from your computer. The analog card that you get actually reads its own voltage, so you can read out what your battery voltage on the robot is and determine whether you need to change the battery or not. It's quite a handy feature to have. We get a digital card, 2 digital cards with this, which allow digital inputs and outputs to be read and to be written to. So you can read the input from a switch, an on-off switch. You could put a switch on the front of your robot, so when your robot drives along and bumps into something, that switch will close. That sends a digital input back through one of the digital input cards on the compact Rio, and that tells the robot, stop, don't go any farther, or back up. Typically how we use the switch is we would have maybe an arm on the robot, and when the arm goes down all the way, it contacts a switch. That tells the robot the arm is down at the lowest position, so don't try to move me any farther. So the software would read that switch, and it would have a small software loop saying, if that switch says that the arm is at the bottom, then don't allow that motor to go forward anymore. So you can write a little routine with a few lines of code. The other module that we get this year is a relay card. It's got 8 relays in it for driving higher current devices. One of the things that you'll get in your final kit, which you get on the 3rd of January, is you'll get a pneumatic system, an air pump and pneumatic switches, pneumatic solenoids. And that relay card can directly drive the pneumatic solenoids to turn airflow on and off, so you can have parts of your robot powered by compressed air. And that's what the intention of that solenoid card is. The other important component on the robot is a speed controller for the motors. This is, you get 2 of them this year, 2 different types. You get the Jaguar speed controller, which is a new speed controller for this year. It's the one on the lower right corner of this photograph, rather a futuristic looking thing. The speed controller is kind of like an amplifier for the motors. The motors that drive your robot take a lot of current, and the microcomputer that's powering your robot is not able to deliver very much current at all. So what it does is it delivers basically a coded signal called a pulse width modulated signal, which is sent through a 3-wire connector to either of these 2 motor speed controllers. That pulse width modulated signal is basically going on and off at a fairly high frequency. And the longer that it stays on, the more power is delivered to your motor. And the longer that it stays off, the less power is delivered to your motor. So if you looked at that signal on an oscilloscope, you'd see a square wave going up and down, up and down. And as you push the joystick farther forward, the width of that square wave gets wider and wider and wider. And what that does is it tells one of these speed controllers to provide more power to your motor. It switches the 12-volt signal, big heavy-duty 12-volt current to the motor on for a longer period of time, and then off, and then on, and then off. So what it's doing is it's varying the width of that pulse, which is why it's called a pulse width modulation technique. It's a very common method that's used to drive electric motors. If you guys ride the metro anytime, the motors, the electric motors on the metro are driven by a pulse width modulation control system. And when you get in the metro train, you often hear a high-pitched whine, a kind of a screaming noise coming from the motors, a very high-pitched squeal. That's the pulse width modulation system that you're hearing, driving those motors with a variable pulse width. And as the driver of that train is accelerating away from the station, he is providing a wide pulse width to those motors to turn the motors on for a longer period of time and then off, on and then off. And as he slows down coming into a station, the width of that pulse that's going to those motors gets narrower and narrower, so the motor gets less and less power and the train slows down. These devices work in exactly the same way. A little less current, a little less voltage than you'd see on a metro train, but essentially exactly the same system. The other thing that you're going to get this year is a video camera. It's quite a powerful little internet-type video camera. You can mount this on your robot and you can look at what the robot is seeing on the laptop computer connected to the driver station. So you could drive this thing around in the next room using the screen on your laptop to figure out where that robot is going to go. This particular camera and the software that comes with the robot this year is a very powerful system. The camera can recognize shapes, sizes, colors. The software that comes with the computer can relatively easily be programmed to recognize shapes, sizes, and colors, and where they are on the screen, left, right, center. So you could very easily write an algorithm, a program this year, by dragging a few boxes around in LabVIEW that says, make my robot go towards the red light. And it looks at the screen, the software will look at the screen and say, oh, I see a red square over on the left. So I'll drive until that red square is in the middle. So that means you're going towards that red square. So you can have your robot programmed to drive towards something that's red. There's also an optical character recognition program that comes with this year's robot that you can use to program this camera to read signs. So I don't know what the game is. There's one person in the audience here who does know what the game is this year, and I'm sure he's not going to tell us anything about it. But a very interesting thing that you could do with this robot is to read a road sign. So maybe this year's autonomous period would have a road sign that says turn left or turn right, and your camera has to read the road sign and figure out which way it's supposed to turn. We'll just have to wait until January 3rd to figure out whether they're going to put something like that in. But this camera can certainly read road signs. You may think, well, this is, how would people use this in the real world? Well, it turns out in Europe, if you buy a late model car in Europe, a Mercedes, a BMW, it has a camera in it that reads the road signs. And it knows what the speed limit is. And if you exceed the speed limit down the Autobahn, some sections of the Autobahn have speed limits on them, 120, 140 kilometers an hour, the camera reads that sign. And if you exceed the speed limit that's on the sign that you just passed, it beeps a little beeper to tell you that you're going faster than the speed limit. So that's how this technology is being used today. Train systems are being set up so that the train, as it goes by a speed limit sign around a corner, the camera reads the speed limit on that sign and alerts the driver if he's going too fast. So very interesting applications for optical character recognition. And we have that system right on our robot here. Another device that's on the computer that's connected into the main controller is a relay. This is a device called a spike. I don't know where the name spike came from, but we call them spikes because that's what it has printed on it. It's a small high current relay. It can turn on and off fairly high current loads like a motor, a powerful motor. You normally use this relay to turn on and off the compressor motor on your robot, or a small motor, another kind of motor, or turn on and off a light. One year we had a fairly elaborate plastic elevator built on our robot. And so we put on some lights that shone underneath this thing and lit it up. And we used one of these relays to turn the lights on and off. Didn't really do anything for us, but it looked neat. The other thing on your robot is a square block called a wireless bridge. It's the radio that connects your robot to the driver station. It's basically a Wi-Fi adapter like you might have into your home computer system. Not a very interesting thing, you just plug it in and away it goes. You all got in your box of tricks a big wiring card like this that gives you a general overview of what all those components and parts are that I just talked about. So I'm going to talk now about the power distribution on the robot with the connections, where the wires go.